Saturday. Today, I'll be looking into LangChain as soon as I find the website, and I'll share the screen. And then we'll get started. There it is. Share this, the whole screen. All right. Okay. Let's close this. Close this, and let's make this bigger a little bit. There we go. All right, so let's see what this is all about. So LangChain, LLM apps from prototype to production, context-aware reasoning applications with LangChain's flexible abstractions and AI-first toolkit. What does all this mean? So it is Python or JavaScript. So I'll go with Python. Feel like it's easier to start with Python than JavaScript. But anyway, so set of powerful building blocks. So there are components, okay. Text splitters, models, tools, selectors, prompts, vector stores. All right. Okay. Swappable components. Okay. Yeah. So it's like a generic interface, I guess. And you just swap Pinecone, OpenAI, Anthropic, whatever you want to use as a backend. So LangSmith, that sounds like it's something else. Okay, one framework, infinite use cases. Yep, okay, ready to build. Yes, let's go to docs. All right, so LangChain is a framework for developing apps powered by LLMs. It enables applications that are context-aware, so connect the language model to sources of context, prompt instructions, few shot examples, content to ground its response, etc. Rely on language model to reason about how to answer based on provided context. Okay. Several parts. So LangChain libraries, so Python and JavaScript, interfaces, integrations for myriad of components, basic runtime for combining these into chains and agents, and off-the-shelf implementations of chains and agents. Okay. So I'm thinking this might be like last time I was looking into the assistance API, and in the assistance API, you would create a thread. You can provide like I guess some context, right, about what the assistant is about. And then you add messages as a user. You add messages to the thread, and then you run the assistant on those messages to get an assistance response. Now, you can do that. I think you could do that without the assistance API, but you would have to be the one who manages the context and makes sure that like all the messages are preserved or getting sent, et cetera, et cetera. So that makes it easier with the assistance API. Now, this sounds similar. So it would allow me to do something like that, I guess. So I can implement the chains. I'm assuming the chains here are requests and responses, right? But we'll see. So there's the next thing is that templates, collection deployable reference architectures for a wide variety of tasks. All right, so we'll see what that is. And then LangServe. So deploying LangChain chains as a REST API. Okay, so that makes sense. And then developable platform. Okay, so this is probably what they charge you for, my guess. Or maybe not, but I would assume that's what they would charge for. Yeah. Like observability, monitoring, event feedback, testing, debugging. Okay, so applications, chains, agents, executors, common app logic, and then integration with models, with retrieval and agent tooling, whatever that means. So the retrieval, I've looked at all of these, I think, in previous streams. And then protocol, LangChain Express, so they have a language as well. Parallelization, fallback, tracing, batching, streaming, async composition. Okay, so Together, these products simplify the entire app lifecycle. So write your application in the LangChain, LangChain JS, hit the ground running. Okay, so you can use the templates, use the LangSmith to do all the production stuff that you need to do, I guess. And then deploy, yeah, so you do an API. Okay, sounds like an interesting, I'm going to call it wrapper for now because I'll probably change my mind later on, but I'm going to call it a wrapper for now. Wrap around the like these different components. So libraries, domain value props, components. Components are modular and easy to use. Yes, off the shelf. Okay, so get started. So here's how to install, set up your environment, install building. We recommend following quick start. Okay, so we'll do the quick start. Does this one have, yeah, so this quick start has the installation portion as well. Okay, so let's do this. I have the browser and I have the code thing here. So what I'll do is I'll just create a virtual environment first. And then we'll activate that. Okay, and then to install LangChain, run pip install LangChain. Okay. Sounds simple. Okay. So using LangChain, you usually require one or more model providers. Yep. So we'll use open. Yep. Let's do open API. I did set my key beforehand already, so I have that. And then, yeah, okay. All right. So many of the applications you build will contain multiple steps with multiple invocations of LLM calls. As these applications get more complex, it becomes crucial to be able to inspect. Yeah, I agree. LangSmith. Note that LangSmith is not needed. Okay, so you have to sign up. Let me just see if they have like a free tier or something. Let's move this to the front screen and I'll sign up here. Just want to see what they have or what they don't have. So let's see. So welcome. Oh, it's closed beta. Okay, I'm on a wait list. That's good. If you're waitlist, you can still access and interact. Okay, I'll leave this open, but it's still in beta, closed beta, so I don't think I'll be able to do this. And then LangServe. Okay, so this is to actually do the REST API, so expose whatever we build through REST API. So you don't need to use LangServe to use LangChain, but yes, yeah, let's do this as well. Oops. Okay. All right, building. So LangChain provides many modules. It can be used to build language model applications. Modules can be used as standalones in simple apps, and they can be composed to run multiple complex use cases. All right, that makes sense, right? So you might want to start with a like user prompt, I guess. Well, user writing something, right? And then based on that, you might want to generate an image, or you want to like recognize something on the image, or run different modules, I guess, not the same thing, right? So this promises to make it easier to compose these things. So it uses LangChain expression language. It defines a unified runnable interface that many modules implement, making it possible to seamlessly chain components. Okay. The simplest and most common chain contains three things. So chat model. So the model is core reasoning engine. To work with LangChain, you need to understand the different types. Okay, prompt template. This provides instructions to the language model. This controls what language model outputs. Okay, and then the parser. So the translates the raw responses from the model to a more workable format. So this sounds like a similar idea to. I'm not saying it's the same, but it's sounds similar as defining a function with OpenAI and saying, hey, I want you to extract these things out and parse it into a more workable format. So then you can go and either like output, or in that case, call a function, right? So I'll cover these individually and then combine them. Perfect. Okay, so two types of language models, LLM. String as an input, returns a string as an output. And then chat model takes a list of messages as input and returns a message. So I'm assuming list of messages here would be back and forth conversations, maybe. String is simple, but what exactly are messages? Base message, yeah, content, usually a string, and then role. Yeah, so role would be like user, or I think agent, assistant, or whatever the second one is, right? And then several objects to distinguish between roles. Oh, there you go. Human message coming from a human, AI message coming from an AI assistant, system message coming from the system, and then function tool message containing the output of a function or tool call. Okay, so in this case, is it the who invokes the function? Because in the OpenAI thing that I looked at, the functions were invoked by like the app itself, right? Or you as a developer, right? You would have to invoke invoke your actual function and then send that back as a message. But this one is telling me, okay, well, we'll see. We'll see. If none of those sound right, there's also a chat message class where you can specify the role manually. Okay. Common interface. So the simplest way to call an LLM or chat model is using invoke, synchronous call for LangChain, takes a string, returns a string, takes in a list of base messages, returns a base message. The input types are more general. We can assume LLMs only take strings. In chat, okay, so chat models take a list of messages, and a message is combination of a role and the content, which is typically a string, and then LLM is just a string, right? Go deeper. Okay, so let's see how this works. Different types of models. So let's import an LLM. So let's do this. New file, main, a lack of better naming. And we'll copy this. So we'll import from LangChain OpenAI, and then we'll import the chat OpenAI. Yeah. Okay. So this is, oh, okay. So this is chat, OpenAI specific chat class, right? So they might have others as well. Okay. And then chat model. So effectively configuration, you can initialize them like temperature, others pass them around. Okay. And then we can do import from the schema. We can import a human message. That should be called user, not human, I guess. But all right, so good company name. So this is the actual like text prompt. Let's make this. Oops, resize a little bit. All right. Where was I? Yep. So messages, and then we can invoke the LLM. So we can use LLM to invoke this, and then just passing in the string. And then okay, so for the chat model, we're doing the same, but so we have the text that's being passed. Let me just put it this way. And then for a chat model, we're passing in messages, where there's only one message with the same content with the role human or user, I guess. So let's do Python 3 main. Let's run it. I hope I have the API key set. Oh, I should probably output something, right? So let's do print this, and let's print this. All right, makes sense. So, and the first one is just a string response. The second one is base message, right? Which is only has content. Looks like it doesn't have a role, right? All right, so let's see. Let's go deeper. Support and input. So both LLM and chat model evoke support and input any of the unit string list. Okay, prompt value. Prompt value is an object that defines its own custom logic for returning its inputs either as a string or as messages. Okay, all right. We can open this in case I want to go through it. Oh, there's not much to it there. It's the core element. It's the model, building blocks to interface any model, prompts, chat. Okay. Okay, so that sounds the same as it was in the first page. So input, output, model, IO. Okay, so format and then predict and fudas and then parsing it. Okay. Okay, so you can do a specific output in a specific format. They're important, subtly but importantly different. So LLMs and LangChain refer to pure text completion. The APIs they're wrapped, take a string. Okay, this is the same. Yeah, chat models are backed by LLMs, but tuned specifically for. Oh, okay, so it's tuned for having a conversation. Crucially, their provider use different interface than pure text instead of a single. Yeah, okay, that makes sense. So chat versus just string in, string out. So most LLM apps do not pass input directly. They will add the user input to a larger piece. Yep, prompt template. You provide an additional context. So we pass the model instruction. It would be great if the user only had to provide the description of the company without having to worry about giving the model instructions. Okay, so without giving these instructions, we would just describe the company. So the prompt templates, that's another object, right? Helps with exactly this. So they bundle up all the logic for going from user input into a fully formatted prompt. So this can start off very simple. For example, a prompt to produce the above string would just be, so let's do that. Let's import the prompt template. And then we'll create a prompt. Let's comment these out for a second. So prompt template from template, what is a good product name for a company that makes fill in the blank product? Okay. So then we do format, and I'm assuming this will just return a string with, let's print this out. But I'm assuming it's just going to be a string that says, what is a good name for a company that makes color for socks? So let's do that. Yep, exactly. All right, so this is just making this more generic. However, the advantages of using these over raw string formatting are several. Okay, yeah. So the next thing would be, well, I could just do, right? I could do something like this. Right? Or I could ask the user, right? I could say input, describe the company, right? Describe the company. And user would give me this input. And I would just replace it here, right? So how is this different and or better than this? So let's see. You can partial out variables. Example, you can format only some of the variables at a time. You can compose them together, easily combining different templates into a single prompt. For explanation, see the section on prompts. So let's see just an example. Set of instructions. Okay, so prompt template. So let's look at this one, if there's anything here. Tell me, okay, so this looks number of variables, including no variables. Okay, for additional validation, you specify input variables. Okay, that's interesting. Yeah, so we can make sure that it's provided. Chat prompt, template. Okay. Trying to see a more complex example. Maybe it's here. Dynamically. Oh yeah, maybe it's this one. Why did I open it there? Let's put it here. So if you have a large number of examples, you might need to select which ones to include. The example selector in the class is responsible for doing so. So the base interface. Select example. Select which examples to use based on the inputs. The only method it needs to find. I want to see an example. There you go. Custom example selects randomly from a given list of examples. I would love if this would be more like a specific example on how I would use this, not just foo 1, 2, 3. Okay, but I guess these would be then like some prompts, maybe, or I guess examples. Maybe example is trying to figure out what is an example of this this context, but we'll see. We'll hopefully get to it. Prompt templates produce a list of messages. In this case, the prompt not only contains information about the content, but who is, the role and the position of the list, because it's important, right? The position as well as who is saying what. Lista, each chat message, its role, and then also its content. So let's look at an example. So let me remove this. I'll comment this out. Just do prompt templates. And then let's do this one. It's the same, similar thing, but instead of doing prompt template, we're doing chat prompt template. And I'll just copy the whole, oops, this. All right, so your helpful assistant that translates input to output language, and then human template is just a text, so it's whatever the user will enter. And then create the prompt. It consists of a system message, which tells the tells the system, right, what is it all about, right? So they're there to translate. And then the human template is just whatever text the user will enter. And then chat prompt is an instance of the chat prompt template, and it's going to format the messages with input language being English, output French, and then text is whatever the user entered. So this will, if we print this out, we'll get I'm assuming the list of messages, right? Yeah, there you go. So it's a system message, and then a human message is I love programming, and then we can do messages, right? Like do this, and then we can just invoke it, right? So let's invoke it here. And I don't speak French, so we're gonna sure. I guess that's the correct response. Okay. All right. So this makes sense. Makes it easier, I guess. It is easier to like templatize everything like this. Yeah, you can do it with like Python specifically with just f strings, right? But definitely useful. All right. Let's see the output parsers. So, what did I click? Okay. So output parsers convert the raw output of a language model into a format that can be used downstream, i.e. later on. So there are a few main types. So convert text from LLM into structured information, convert chat message into just a string, get the content out, I'm assuming, and then convert the extra information returned from a call besides the message. So OpenAI invocation into a string. Oh, okay. Might be whatever OpenAI, any extra stuff that OpenAI returns. Maybe you can include that in a string as well, but we'll see. So let's see. So in the get starting guide, we'll write our own output parser that converts a comma separated list into a string. Okay, so we have to do a separate class. So let's do that. Oops. Base output parser. Let's do it here. And down here, we'll do this class. So, so parse the output of an LLM call to a comma separated list. Okay, so, and then comma separated list output parser hi by. Okay, so how does this, let's print this out. Okay, makes sense. Just writing a parser, but how is this? let's look at the output parser. So language model output pair, main times you want to get more structural. Parser classes, there are two main methods. Get format instructions, a method which returns a string containing instructions for how the output of a language model should be formatted. So we don't have that here. And then parse, we have that, a method which takes in a string, assumed to be the response from a language model, and parses it into some structure. And then the optional parse with prompt takes in a string and a prompt that generated that string and parses it into some structure. The prompt is largely provided in the vendor output parser wants to retry or fix. Okay. All right. So there's a more involved example, I guess. Let's look at this one. So desired data structures, joke, setup, punchline, question. Okay, so these are just strings. You can add custom validation. All right, so this is already like creating a model. I think I haven't covered this one yet. But then we can set up a parser plus inject instructions into the prompt template. So Pydantic, I don't know what this is. I guess this is one of the built-in parsers. And we pass in the object. So this one, the joke. And then in the prompt template, we're saying, so answer the user query, format instructions, and then whatever the query is. So the input variable is query. It's this one. And then partial variables. Okay, so this is that that portion where they were saying, oh, it's more powerful than just a string, like a normal string interpolation, right? So partial variables format instructions. So this will get replaced with this. And we're calling the parser get format instructions. Okay, I'm curious what this one returns. And a query intended to prompt a language model to populate the data structure. So prompt and model. I don't know what this, anyone knows what this does? This operator here. What is the operator in Python? What is it? Well, maybe I'll just call it pipe operator, right? Pipe is a module. Is it pipe? Pipeline? What do you call pipe characters, right? Oh, it's or. Okay, but so if it's not said, it's just or. Okay, makes sense then. Wasn't sure. So it's either prompt, this one, or model. I don't know. Prompt and model, or maybe it's end in this case. So we're invoking, passing in the query. It says, tell me the joke. And then parser, we're invoking the parser on whatever the output of this prompted model invoke is. And then what we get back is we get this, I'm going to call it strongly typed joke object with the setup. Okay, so with this one, so questions to set up the joke. So this was the, and then punchline was the actual joke. So these two are attributes in that object of the joke, right? Joke class. It then ends with question validator, Pydantic. Okay, so I don't know what this Pydantic thing is. Oh, it's a data validation. Oh, okay, so it's just a data validation library. So we can use this, maybe that's why. Oh, anyway, okay. Hopefully they have, like, this is not telling me much, but this one is telling me more, but it still feels a little bit like complex because I'm not sure what happens. So answer the user query, format instruction, get for, where's the get format instruction coming from? That's, well, let's do this. Let's copy this and let's try it. So let's create another one. call it joke.py, and we'll see what the different pieces of this are. So I'll set up this joke, and let's see what's the base model. Init, no. JSON, parse object, parse file from ORM, copy. These are just basic, like base class things from the base class. All right, so prompt. I get this input variables. I get this as well. This is referring to whatever is in the template. Partial variables, format instructions. Parser. Oh, parser get format. So let's see what this one does. I'm curious what this one will return. What is the get format instructions? Maybe this is. It's not tied to the template, right? So it's just tied to the parser. So is it? It needs the setup and the punchline. Is that the format? So Python 3 joke. Okay. So this is like. Okay. So this is something coming from whatever's in the base class that like sets it up. So the output should be formatted as JSON instance. So this is the actual prompt, right? Formatted as JSON instance that conforms to the JSON schema below as an example for the schema. Okay, so this is just an example, right? It's telling the LLM how gives it an example how like schema, gives an example of the schema and then an example of a well-formatted instance and then an example of a bad or not well-formatted. And then it's actually saying this is how our schema looks like. And our schema is then based on this setup and punchline, right? So setup, title is setup description, type is a string, punchline is title, punchline, okay. And then both of them are required. Okay, so this makes sense then, I guess. So this will then end up, let's print out the prompt. So I'm assuming this will then end up being as a system message probably. Let's see. Template answer. Oh, no. This is just doing the. I was expecting this to look like. I'm assuming at some point it does end up being this thing, being like part of the system message. Well, this does, right? Okay. All right. So templates, so the format instructions that are generated based on this class and the fields that we specified in the class become part of the system message, right? Telling the model how to format the responses, and then the actual query will be tell me a joke. And let's see what this prompt or model thing does. Prompt and model. First, prompt template. Prompt template, so it includes the prompt, but it also then includes the model down here, right? Does this do like a tuple or something? Let's see. I think that's how you access the tuple, right? How do you access Python tuple values? Indexing, okay. Oh, it is as an array. So the first one should just, no, it's not. It's not subscriptable. How would we get check the variable type and Python type function? Okay, type. I haven't done Python in a long time. And I've never done it like professionally either for work. It was only like one-off one-off scripts. So it's a runnable sequence. Okay. So it is a sequence. Oh, so it does this one first, and then whatever's the output, it runs it uh, uh, as a right as an input to the model itself, right? Okay, so it is a sequence. Okay, so sequence. This is a sequence. So if I could have, like, I'm assuming I could have more stuff here, and it would just call them in a chain, hence the name LangChain, I guess. Okay, this makes sense now. So prompt and then output, we're just invoking it, right? We're invoking this chain, passing in the query because that's the only input variable that we have, and this is something that would, like, user would type this in, right? And then we get the output. So let's see what the output is, because on the output we're invoking, like, we're passing it into the parser. Okay, so we get back the setup and punchline. So these are the two, right? Setup and punchline. And then this is being passed through the parser. So parser, and the parser is going to output. No, nothing, because I don't have print, right? If I do print, it's going to output something. Let's do this. Oh, okay, it's just pre-prints, I guess, whatever this does. All right, so this kind of makes sense. So that's a sequence, a chain. Oh, let's call it a chain, since that's the name of the library, right? So this is a chain. Does the prompt first, and then does something else, right? So I'm curious if we could do like an example of what we could do here, but let's go through continue going through the docs, and then I'll see if I come up with a good example on how to modify this and how to do it differently. Oh, I just noticed my screen is very small. Maybe this is better. Yep. Composing. So let's see what we're composing here. Composing with LCEL. LCEL? Is that how you pronounce this? Maybe. I don't know. Let's see. Just check. Yep. So we can combine all these into one chain. Oh, okay. Now it's going to explain the thing. If I only continued reading, it would tell me what it is. So you can combine all these into one chain. So chain will take the input variables, pass those to the prompt template, yeah, just like it did there, and then pass the output of the from the model through an optional output parser. So a convenient way to bundle up a module or piece of logic. So let's see it in action. All right, let's go back here. So we have the comma separated thing, and then we have the template. Yeah, let's do the template. We have to print this out. So you are a helpful assistant who generates comma separated list. User will pass in a category. You should generate 5 objects in a comma separated list. Only return a comma separated list and nothing more. And then we'll create the chat prompt, template being the system template, right? So this would be system template. And the human template will just be whatever the input will provide. And then we're doing the chain here. There it is. If I only read, continue reading here. But anyway, so chain is chat prompt gets passed into, I'm assuming, chat OpenAI, which is, we could just do this, right? Chat model, because we have it instantiated up there, and then to a comma separated list output parser, and then we can invoke it. Chain.invoke text is colors, and then this will result and print the result. Go. Let's run this. Should give us an array of, yeah, perfect. Okay, there. It's all here. There's a tip for you. Continue reading instead of wondering what things are. Or using the pipe syntax to join these components. It's powered by okay, yeah, it's runnable, what we've seen. And yeah, all of these objects implement the runnable interface. Therefore, that's why you can do this. Okay, this kind of makes sense. You can chain the things together, and then what you could do here is once you get this input, you could chain it further if you wanted to, or actually create a second chain that you would invoke. Makes sense. All right, so let's look at tracing. So assuming we set the environment variables, we didn't because, we don't have access to this. So I'll skip this one. Check what the trace of the, let's take a look how it would look like. Oh, nice. Nice. This is useful. This is definitely useful. Yep. Yeah, this is definitely useful for debugging, right? So it shows the prompt. What was the input? What was the system prompt? What was the system prompt? What was the human input? Feedback, extra metadata. Okay, not sure what feedback here is. And then we ran that through the LLM. Yep. And we got back comma separated list of colors. And then we ran that through a parser. So the input was the colors. Okay, so this is where those examples would come in. So we could add more examples, I guess, just like we did. In that previous, in the joke one, right? I'm assuming. Wait, where were those? Those examples were the get format instructions, right? Pedantic, pydantic, parser. Does this one have? So if I create base model, this is just a parser. That over there we actually had a model, so that was different. Okay, and then this outputted the values in an array, and then similar metadata. Yeah, this looks pretty good. Oh, it actually shows you the number of tokens as well. Interesting. It's definitely useful. You can see how this could be helpful for debugging. So let's go to the survey. So we build the app. Now we need to serve it. So that's where LangServe comes in. And LangServe deploy these chains as a REST API. Okay, so integrated fast API. Okay. So we need to create the server. So let's do the, what are they calling it? Serve by serve dot. Oops. By definition of the chain, same as above. Okay, so this is the exact same thing that we had before. So let's copy this. And then the second portion is the Fast API app. I'm assuming Fast API is some Python framework. It's a framework for building high performance, easy to learn, ready for production. It's like, it's Python. I guess Python based library. Yeah. Okay. All right. So define the chain, and then we're defined the app definition, the LangChain, the Fast API thing. Did we import? Did I install? So let's do Fast API. I did. It's there. Yeah, simple API. Okay. And then we add a route. To this Fast API. the chain, category chain is the chain of the prompt, the model, and the parser. And then path is just where the path is available. And then this is just hosting it, right? Or serving it, I guess. Okay. So let's see if we run this. Python 3 serve. Okay. Using, oh, I have a newer version, I guess, or something. Anyway, so it's running. So what that means, I can, yeah, so I can just, actually, I can actually open it here instead of just curling to it, right? So we can do localhost 8000. Yeah, there's nothing there. Category chain. So this is the actual endpoint, I guess. Playground. Oh, nice. Yeah, so my input would be, let's do countries, right? Start. Nice. Yeah, perfect. It reminds me of the GraphQL endpoints. I don't know if they call that playground or not, but similar thing where you can run the queries and you get the output. What is the share? Oh, just sharing the actual direct chain, I guess. Is it? Or not? Anyway. All right, so playground, but there's, let me move this out of the way. So we can set up a client for programmatically interacting with our service. We can do that with remote runnable. We can interact with the surf chain as if it were running client side. Okay. Okay, so we could do client, right? So let's do client. Yeah, and then if we do Python 3 client, I call it made a call, right? Oh, man, I have to print it out, right? Yeah, perfect. So what you could do is you would, whatever was here, the serve, right? You would go and deploy this and or run this, expose it publicly somewhere, I guess. And then you would have an API endpoint that you could call from your code, right? And since this is both Python and JavaScript, you could have, there's an equivalent code like this for JavaScript, right? Where you can invoke the endpoint, right? And I'm assuming you could probably figure out there's also a way to just use like a curl, right? Because that's all, like you need an endpoint, and this is somehow passed over to this post or whatever. Well, let's see. Want to try this or not? So let's do this. So if I do curl post this and data, let's see if we can post this. I don't know if this is going to work. No, it's not. It's probably some other, it adds something to the endpoint somewhere, but you could probably figure it out. All right, so we touched. Yeah, it is a post. It's a post to chain. Oh, it's chain / invoke. Go. All right, there you go. Yeah, almost there. Yeah, it's just a different type. Yeah, it's not just this. It's probably a different. It's probably that whole output that you have to send. Anyway, there's a different format. Next step. So we touch on this, and now we serve it a lot more. LLMs from key components. All right, so let's see what's next. Security. Yeah, it's kind of makes sense. Nothing specific here. Language expression. LangChain expression language. You can also do streaming, so you don't have to wait for the whole thing to finish. You can get the as the responses are being generated, you could get them back or show them right away. Things can be parallelized. Okay, there's a typo here. If anyone wants to fix it. Retries and fallbacks. Yep. Access intermediate. Okay. Yep. So let's take a look. Prompt, model, output. Yeah. So we have this. We did something similar, but now we're using the string input parser. So let's take a look. Let's do this. I'll exit this one. And what do we call this? What is the... Oh, it's language expression thing. So let's do LCEL pi. And we'll copy this. So this is same thing that we went through. String output parser is to the top likely string. Okay, so this just gets a string, I guess. Prompt is tell me a short joke about some topic that you input. So we could do prompt. Prompt is going to have the topic of ice cream. That's going to be passed into the chat OpenAI model. And then whatever chat OpenAI returns, we're going to parse it, run it through the string output parser. Okay, so let's print this just so we know something has happened. Python 3 also apply. All right, perfect. Okay. Need like sound effects here for all the bad jokes. Let's do tell me a short bad joke about the topic. It's gonna be any better? It's gonna be worse. Scoop esteem. That's pushing it a little bit. But anyway, definitely interesting. Okay. Notice the line. Yep, we chain it together. Yeah, Unix pipe operator. Yep. Input. Yep. Template passed to the model. Model passed to the parser. Perfect. So prompt is yep. We know that. Prompt value is a wrapper on completed prompt or chat model. Yep. Okay. So yep, we can convert it to messages as well. Oh, that's nice. All right. And then the second portion is the model. Whatever the prompt value is, it gets passed to the model, chat model, outputs a base message. If our model was an LLM, it would output a string. Okay. LLM invoke. Oh, okay. So and then finally the output parser takes either a string or a base message as an input, simply converts any input into a string. Okay. And then the whole pipeline. Yep. Oh yeah, this is a nice visualization here. They should have this in that main docs. First time that they show the, actually it was there. I just wasn't reading it, reading far enough. Okay. Smaller version. Yeah, just see makes sense. All right, RAG search example. So what we want to do is we want to run a retrieval augmented generation chain to add some context when responding to questions. Okay, so so vector store, we're doing an in-memory search from some text. Harrison worked at Kensho. Bears like to eat honey. OpenAI embedding, so it creates those vectors, right? I've seen that in, I think video 1 is when I went through the embeddings, or video 2 maybe. Retriever, vector store as retriever. Okay, so it's something that we're gonna, set up and it's there. All right, so answer the question based only on the following context, and then we pass in like whatever the context is. I'm assuming it's going to be this vector store somehow. And then the question, whatever user is going to input. So we create the prompt from the template. We have the model, which is chat OpenAI, and then the parser. And then we have, this is a new one, right? Setup and retrieval. So runnable parallel. Context is going to be this vector store of OpenAI embeddings that are created from these strings. The question is going to be runnable pass-through. Okay, I don't know what that is yet, but we'll see. And then the whole chain is, yeah, it does setup and retrieval. So it sets up the vector store, well, the context, and I don't know this question runnable pass-through, what this actually does. Then, oh, maybe it's it knows to connect the runnable pass-through. Like, where did Harrison work? We know that that's the question. That gets like we get it from it gets passed in, like it's a pass through because we're getting it from the prompt. Maybe we'll see. Hopefully, maybe it's explained later on. Probably is. Prompt and then model output parser. This part is the same as before. Okay, so the compose chain is this. So to explain, first we first can see that the prompt template above takes in context and the question as values to be substituted in the prompt. Okay. So before building the prompt template, we want to retrieve relevant documents to the search and include them as part of the content. Makes sense? So as a preliminary step, we've set up the retriever using an in-memory store, which can retrieve documents based on a query. This is a runnable component as well that can be chained together. But you can also try to run it separately. Okay, so retriever, it's this one. Let's copy this so we can run it. What is this example? RAG. So let's do rag.py, paste it in here, and I have LangChain. I don't have Docker array, so let's just do this. It's going to run it through. Oh, it's already done. It's pretty fast. Okay. All right. So template output parser. So if we comment this out from here, we could say, actually, we comment this out as well, right? Based on this, right? So retriever invoke. Yeah. So retriever dot invoke. Where? Oh, wow. Okay. Python 3 rag. So this should, okay, what do I need? Oh, pip install tick token. Is there a GitHub page directly? So let's make this fix right away. So pip, let's search for pip install LangChain docker array. There's no TikTok token mentioned here. No. Where are the docs? Rag, maybe rag search example, right? Oops, not here. Rag search example. Search for this one. There we go. Oh, it's an actual. Yeah, so it's an actual. What are these things called? Oh my god. Notebook. Notebook. It's an actual notebook. So let's do master branch. And we'll go, so it's LangChain docs expression language. So it's docs expression language. Where's the fork? There it is. Yep. Create the fork, and then we'll update this one. Let's see if they can, how fast they'll take this. fix in. So we said docs, expression language, and then get started. Did I have any contribution guidelines? So I'll make sure that I'm following whatever they want me to follow. As an open source, yeah. For details, see here how to contribute. Fork and pull, yeah. Fix a bug, okay. No. GitHub issues, no. Testing, formatting, and I'm not gonna. It's just a small change, so it doesn't. Okay, so if you're adding, I'm not adding documentation. Just trying to see if they're not. I don't think they have any guidelines on how to. There's a specific way that you have to call the like prefix the PR or issues or something like that. There you go. LangChain tick token, right? Was this the one? Yes. So commit changes, and we'll see docs, add missing tick token dependency. And we'll say I was following the docs and got an error about missing tick token dependency. Adding it to the comment, where the LangChain and doc array libs are. Create. Yeah, I'm not gonna create a commit directly. I'm gonna commit directly to my master because it's just make sure that it renders correctly. Drag search. Yep, doc array tick token. Just double check that that's the actual name. Tick token. Yep. And then let's do a PR very quickly. Contribute, open pull request, tick token dependency, yeah, create pull request. Oh, there you go. I was following that. Description, replace this entire description, issue, so the description. I don't know if it has to be like this. Let's do a description. Issue, no. Dependencies, no. Quick writ, no. Twitter handle, we know it's big for it. Yeah, no. All right. Yeah, should be enough. There's no. It's a small change, small fix. Open request. All right. So it needs an approval. So hopefully it's going to get fixed. All right. Back to this one. So I installed pip token, tick token, pip token, pip install tick token. There you go. What the heck? Why is it now failing? So because the pydantic thing, I don't have the. Remember that earlier issue that I got? Let's see it again. It was when I was serving, it was saying that my version of pydantic was not. Yeah. Well, now input. If you need to see the docs, you can downgrade to pydantic. Oh, let's do this. I don't know if this is going to make any difference. If that's the reason why that error is happening, but let's see. Okay, so let's do this. Now it's taking longer. Yeah, there you go. That's what it was. Perfect. So pydantic, I had a newer version. Should I have an older one, I guess. Maybe that's another issue that would be an issue that one would log, right? There you go. Perfect. Yeah, so it returns something called a document with the content that says here where Harrison worked. Oh yeah, it returns two documents. It actually returns these two things. Why wouldn't I was expecting this to actually run. Oh, maybe because it has to be set up like that. Maybe. So we then use the runnable pair to prepare the expected inputs by using entries for the retrieved documents as well as the original question. Using the retrieval for documents or okay, so runnable pass through to pass the user's question. Okay, so it is what I was thinking about. It is right. So runnable pass through is saying uh, get it from here, right? Let's get passed through the prompt and all that. Okay, so all right, so with the flow being the first step creates a runnable parallel object with two entries. The first entry will include the document. The second will contain the user's original question. To pass on the question, we use runnable pass-through to copy this entry. Okay, so question, let's see. I'll actually uncomment this one. So setup and retrieval. So runnable parallel with the retriever, that's the doc, and then runnable pass through to pass on to the question, right? And then prompt, chat model, string a result. Okay. So now if you run this, that should work. Should actually tell us, well, answer the question. Oh, of course we have to print it out, right? Perfect. Yep, that makes sense. Why use this? So it makes it easier to build. Does a unified interface? Yeah, it makes sense. Automatically support itself an object primitive. Yeah, makes sense. This like I don't think I would have to be convinced why to use this. I mean, it's if you have complex things that you want to chain together, this would definitely be a better way to do it than this. And this is what I've been doing in the last couple of streams. If anyone watched, you will remember that we did right create a response and then response choices message content right and then invoking like doing the first one and the like first one second one and then actually getting the like creating the whole chain right. This makes it way more readable, right? Specifically this one, right? Like, it's more readable than parsing like invoke chain and then call chat model. Okay, back here and do that. Yeah. Anyway, stream the results. We need to change our function. Okay, so instead of streaming, so chain stream. So we could do over here as well. I guess we could say so instead of chain invoke, we can say for chunk in chain dot stream and we'll say where did Harrison work, print chunk and flush equals true. So I think now it should just output as it gets the responses back, right? Yeah, it was just very fast. You can see it. It's yeah, there you go. We can time it and see if it's faster. Oh, it shouldn't be. Doesn't matter. Yeah, but now you could see that it was actually streaming them. Want to run a batch of inputs in parallel? We need a new function. Okay, nice. So you can batch multiple different inputs at the same time if you want to. So you don't have to do it one by one. Async, yep. Instead of chat model. If you want to use a chat completion endpoint, is there a chat endpoint? Okay, yeah. Different provider, yeah. So you can do Anthropic as well. It doesn't. So this makes it very easy to like switch out the models, right? Versus this is like you have to know what the specific model's API is to be able to do that. This one, the LangChain, is going to abstract it away for you, going to get a well-defined interface, right? You can call the same thing. Runtime configurability. I'll configure at runtime. Okay, how does? Oh yeah, there you go. Yeah, nice, even better, right? So you can pass in the actual model that you want to use. So let me copy this here, so it's easier to. Or can I make this? This I don't like it that it's. I have to scroll, so let's do it this way. So you can create a configurable model. Default is going to be, yeah, the perfect. Yeah, this is, yeah, because the chain is exactly the same, right? It's just the model is the thing that gets replaced, and then you can decide which one to call down here, right? Say, oh, I want to call, explicitly say I want to call OpenAI versus Anthropic or whatever you have. That's nice, a nice abstraction. Logging, intermediate results, built-in integration. Yeah, we don't have the line. We've seen that. I've seen this, right? I've shown this. This is definitely interesting. Yeah, there you go. Even better, right? Yeah. So it makes it reminds me of uh, I'm blanking out on the name now, but done any Kubernetes work and any Istio work, you're gonna know what I'm talking about. Is a distributed tracing app. Jaeger. There you go. Jaeger. Jaeger looks very similar, right? Jaeger tracing. Do they have any screenshots? They don't. They should. Show people how this looks like. There you go, right? Looks very similar, right? Yeah, there you go. So you're not tracing over here, you're tracing services over here. Where was it have it here? Right. You're tracing this runnable sequence, which is in the end, it's the same thing. You just want to know what happened at each step. Fallbacks. What is a fallback? If you want to add fallback logic. Oh, okay, yeah. In case one model, perfect. Yeah, let's you burned out your API key usage in one, and then you just want to fall back into another one. Yeah, and then of course, no one's gonna. It's not the line numbers so much, right? Then like this, the thing on the left is so much harder to maintain. Not just maintain. Imagine making changes there. It's a nightmare. All right. Yeah. Oh, it still goes on. There's a full interface. I'm not going to go through the full interface, but we've seen the stream is the interesting one, and then all the other stuff. You can figure it out. Call schema. Okay. Oh, you can get the schema. All right. So let's do. How are we doing on time? There's how-tos. Nice. Passing data through. Oh, these are more involved examples, I guess. Runnable lambda. Oh, lambda function. Runtime, fallbacks. What is a cookbook? Oh, okay. Something like you can go and follow. Prompt is LLM. Yeah, it seems like the most common thing that one would do. Can mix and match things. Stop sequence. You can attach a function call. Oh, and then you pass in the function. Yeah, and then it gets back it parses the setup and the punchline, I guess, right? Setup, punchline, it parses it out for you. So it's the same as the OpenAI functions thing that I looked at. So it's not invoking it for you. However, I'm assuming, can you do? Oh no, it will this invoke it in this chain? Can you configure it that I'm assuming if this will go and actually, since you're passing in function call name is joke, I wonder if you could chain it, right, to say whatever setup prompt bind the function so you could get back this function call, and then the next one that you would pipe in would be the actual function that you have to call, and then you can do something else like parse a string or output parser or whatever it is. More workable format. Oh, they have a, oh nice, you can do a JSON one, so let's see how that looks like. Where did we have, all right, so this was comma separated one. Well, it was the joke one. So let's open the joke one. Joke, joke, prompt model. Can I just do this? JSON output. Oh no, functions parser. Oh, never mind. So this is the functions one. Okay. Key name setup. String function output. So, oh, this one. So when you specify if you want to parse that directly, JSON output functions parser. Okay. Oh, okay. So then you can then pass that in directly if you want to, right? What about parable? Take of creating a prompt input dictionary for you. Foo, composing. Okay. Oh, there's a lot of stuff here. Looks like it's pretty good documentation, I might say. A lot of examples. I like this cookbook style. I think OpenAI has the same, uses the same thing, the cookbook, where they have like articles for where they explain specific use cases. This is what we went through, right? Vector store. Yeah. So vector store. And then language. Oh, you can pass in. Oh, answer in the following language, and then the chain passes it through the retriever. Question is the item. What is the item getter? Is that like a? Oh, it's it's from the Python library. Just gets the prompt and then model and output. Conversational retrieval chain. So we create a template. So given the following conversation, rephrase the following to be standalone. Oh, okay, interesting. So pass in the history. It's nice that you don't have to. What I like about this, it seems like you don't have to worry about like limits. I mean, you do, but the token limits, that is. But what I'm assuming is the LangChain is gonna chunk them up in a way that you don't have to worry about it yourself. So answer the question based on the following context, pass in the context. What is the question? The prompt, page content. Feels like these are like all over the place, or are these like individual examples? Document separator, format, document, just schema, format, document. Get all the docs. Chat history, okay. Condense the question. That's the prompt. This one here. Send it through a chat, OpenAI, and then parse it. And then the context is going to be the question. Retriever is going to combine all this, like create the This is really nice. So this can, if you remember first or second video where I was thinking about getting all my blog posts, this would make it so much easier, right? Because then I could combine all of them, read all of them, right? Use the retriever to do the embeddings and everything, and then actual question, right? Yeah, chat history. Yeah, Yeah. Okay. With memory and returning source documents shows how to use memory with the above. We need to manage that outside at the memory. Okay. For returning the retrieve, just pass them along the way. Conversation buffer memory. Input key. That's the memory. Calculate the stand. Gets okay. These are more involved, but what else is here? Multiple chain. Oh, there's a lot of stuff. Prompt one. Oh yeah, so this is chaining like whatever the output of the first prompt, first chain is, chaining it to the second one with the second prompt. Nice. This is very powerful. Agent. Did I run? What is the agent? Is the agent to? Okay, this looks more. I haven't read about the agent here in this context yet. Writing Python code. Oh, and you can actually run it, sanitize the output, remove the markdown syntax, and then actually go and use Python REPL to run the code. Nice. Routing by semantic similarity. So you can easily add custom routing logic to your chain to dynamically determine the chain logic based on the user input. You need to define a function that, given an input, returns a runnable. So specific use is use embeddings to route a query to the most relevant prompt. That's interesting. Oh, there it is. Video 2, cosine similarity, right? It figures out, you can calculate how close the queries are, I guess. You convert the string into numbers, vectors, and then you calculate how their similarity. Physics template, math template, open them, yep. Create the embeddings. So you create a query, you calculate the similarity, get the one that's the most similar, and then, yeah. So if most similar is math, then we're going to use the math. So if I'm assuming if the query is math specific query, we're going to use the math template. If it's physics, it's physics. And then that's an interesting one. Yeah. Very nice. Adding memory. What is this? So how to add memory to an arbitrary chain. Memory classes, but you need to hook it up. Okay. From message placeholder. This is a new one. I haven't seen that. So memory conversational buffer, return message to, load, history. So runnable pass through, history is lambda, load memory variables. Item getter, so get the history and run it. Prompt, model. Since these are, I figured if these are like notebooks, I could run these directly. They should have this on the web page so you can run these directly here. I think I need to read more about some of the concepts because I'm not like, it's more complex to figure out what these different things are. But oh, nice. You can hook it up into like tools, outside tools, modules, retrieval, agents, chains, memory callbacks. So we went from the quick start directly into like LangChain expression language. Use cases is the one. That's an interesting one. there's an extra thing here. Open and collab. Okay, so this is where you can go and actually run it there. So enterprise data is stored in, oh, it's in a database. I wouldn't call it, but yeah, queries. Nice. So you can hook up an existing database, I guess, with your data. Question. Yeah, it's actually going to do the query the database based on your query. So based on LLM is going to go query it and then run it through LLM again and then give you an answer. Get required packages. So check database. I don't think I have SQLite 3. Oh, I do. Look at that. Let's do what that. Yeah, let's do this one. Let's do this. Let's see if what are the other ones. Summarization, tagging, web script. Let me click through these a little bit. I want to do one. Let's do let's do structured data. Let's do this one. All right. So do I need this experimental? I'm going to install it just in case. No, it's oh no, I was missing something. Okay, so we'll do this. So save this file to a directory. Okay, so let's save it here. College Nuke SQL. Yep. Let's paste. That's a lot of stuff here. A lot of data. Pasted there. Let me just make sure that I didn't paste it twice. Okay, so we have this. Have the data, and then we can run it all. Let's open another terminal here, and we'll do SQLite 3 nuke.db. Okay, and then we're going to read in the SQL file. So this will actually create the tables and insert the values and everything that we need. Let's do that. Perfect. And then we'll, oh, is it still working? Yeah. So we can select everything from artist, and get the first 10 of them. Perfect. So this works. Yeah, so we have the DB there. So I can close this. Oops. Close it here. Exit. No, there we go. Okay. And we'll create the chain to execute SQL queries. So let's close this and we'll call the SQL.py. Let's copy this and see what it does. So we're reading the database, instantiating LLM, creating a DB chain. So this is a chain for interacting with the database, and we're passing in the LLM OpenAI instance, the actual database, and we're just setting it to verbose equals true, and we'll say, oh, this is nice. The employees are there, and let's print this out. Print. Oh, we'll actually get the verbose output. So Python 3 SQL. Nice. So how many artists? Nice. So it knows how to translate the human query, right, the user query, I guess, into the SQL query. Right. So when I ask how many artists are there in the database, it's going to know, like it translates that to select count everything from artists, which makes sense. What is let's see if there's any more interesting things. See if it can combine it, So let's see. How does it look like? I'm not familiar with this database, so I don't really know what the relationships are between the tables to ask a more. Okay, so how many? Okay, yeah, so this is going to be interesting. So let's see. Let's do what is the average? What is the average number of albums an artist has. So I can see there's a table album, there's an artist as well. So we can ask something like this. Okay, not a SQL expert, but let's see. Nice. So, oh, perfect. So it's gonna do an average. Okay, so it's gonna select the artist ID. It's gonna count the albums, right? Album IDs. It's gonna select that into the num albums from the table album, and it's gonna group it by the artist ID, and then it's just gonna do the average the number of albums. This is the result, and then it takes this result and passes it through the LLM again to get the user-friendly output. This is extremely powerful. Wow. Like imagine if you have a database like of I'm seeing the invoices here, right? And um, someone wants to know what is the average. Let's see, what is the average total of all invoices in the past 3 months, right? You could answer questions like these. Maybe this is not going to work, but oh, it's none because the data is probably not. Like, let's see, invoice or total. So 2009. So in in the first 3 months of 2009, the data is like it's not current there, but yeah, there you go. Nice. Wow. This is really powerful. Text to SQL query, yeah. And then you can actually like this is going the whole way, right? It's user input, SQL query, run the query, pass in the results through the LLM again to get the user-friendly output. But you can just say, I just want to get back the SQL query, and then you can do whatever you want there as well. Nice. Oh, and then the what is this called? LangChain trace. Get all the tracing. Nice. This is really, really interesting. Really useful as well. All right, hour and a half. That's a lot of interest. I might do another one on this because it's very interesting. Web research. I like that. Web scraping, web research. Oh, this is actually going to go and use Playwright. I think Playwright is for, I want to say automating the browser, but I'm not. Is it? What is that? I think it was like for automating Playwright. Oh yeah, testing, end-to-end testing, modern web apps. It might be for. Oh, I don't know in what context is it used here, but so what is it doing? So scrapes. Oh, headless instance, Playwright, right? Yeah. So yeah, it's handled by Playwright, so it interacts with the web page. Yeah, so this is what it does. Loads the HTML, and then Beautiful Soup goes and transforms and parses whatever you want to parse from that page. And then what does it do next? LLM with functional web scraping, yeah. Yeah, that's interesting. So it's not just if the web page changes, the structure or whatever, you have to go and rewrite or figure out how to parse it again. But with the LLM, you could basically say, this is how the schema should look like, and go and parse it. Oh, this is awesome. This is really nice. First token, split the process. Nice. And then actually instead of using beautiful soup, you go and say, yeah, go and like use LLM to extract the data that I need. Nice. Anyway, I'll definitely do another one because there's a lot of examples that I want to go through this from here. But anyway, hope this was useful. And I'll see you guys next Saturday, I guess. Bye.